Okay guys, we're going to start this similar to the last word problem set. We're doing problems involving right triangles, and we're doing actual word problems. Now we could end up using sine law or cosine law as well, but there'll probably be a right angle in there as well that we can work with. So we'll do it the same as before. I'll do a rough sketch, then I'll delete that and show you the really pretty sketch. So first one. From the top of a 120-meter cliff, two boats are observed in the same direction so that the angles of depression are 21 and 31 degrees. Find the distance between the two boats. So again, start off drawing your cliff. Nothing too crazy here. We have our water. We see two boats. Our cliff is 120 meters. And we have our angle of depression. Now remember, as part of our angle of depression, we have to look straight out. And our angle of depression is the angle that you're looking down at an object. So we have two of them. One of these, that's our smaller one, so that's going to be our 21 degrees. And then we have our larger one here, which is 32 degrees. And they want us to find the distance between the two boats. So this distance right here, which will be x. Our cliff, since they gave us the height, will be standing straight up. So we end up having three triangles here. We have the large one, we have the smaller one, and we have a funny one sitting inside right here. Okay, so sometimes it helps to actually have a piece of paper and do a rough sketch first, and then when you do your solution you can do the nice one as part of your solution. So let's see what a nice picture looks like. So here we go. I've put some labels on it as well. We've got A, B, C, and D. Take note of this line right here. Since the angle of depression is equal to the angle of elevation, we have angles within the triangle. So again, from grade 9, maybe you'll remember the Z pattern. Since the horizontals will be parallel, this is parallel to this. This 21 inside this Z right here will be the same. And in this larger Z pattern right here, 32 and the 32 will be the same. So if you want, you can say let x represent the distance between the boats, and then we can label that on our diagram, x. Again, I have some extra angles that I can calculate right away that might help me out. Let's add those. So I've gone and added the angles that I can find very easily. Right here, I have 148 because of the 180. It's a straight line minus the 32 gives me the 148. Again, I have a right triangle here with the 32 degrees, which would make this not 78 but 58 degrees right here. And this little one right in here is 11 degrees. Now I might not need all of them, but now I don't have to think about it if it does come up and I have to include or find those out. So let's take a peek. I need a piece of information from this triangle right here. I need to figure out what x is. So I'm going to need to use one of the other two triangles to find out some piece of information, probably a side length in that triangle. So I'm either going to want to figure out what this one is, this side length, or what this one is. So I'm going to circle my 21 degrees. And I can do opposite over hypotenuse, and we'll call that y to make it easier to make reference to. So let's go and find out what y is, and then at the very end I'll be able to use y and my 148, so probably the sine law. So let's go and find out what y is. I get sine of 21 degrees is opposite over hypotenuse. Rearrange. Take the y up and multiply it. The sine 21 will come down and divide it, and I get 334 and some change. I take extra decimal places because I'm going to be using it in a future calculation. And if I look here, I have an angle 148 and an opposite side that I know. So I'm going to circle that. I know this and this. Those are opposites, so that means I can use the sine law, and it's showing right here. I want to find out what x is, so I need this, and straight across will be my 11 degrees. So I get it right here. And then rearrange, so I bring the sine of 11 degrees up and multiply it, and I get 120.6. And then if you look a little lower, just the therefore statement, therefore the boats are 120.6 meters apart. So I included the units right in the therefore statement, and that's fine. Some people include them here as well, which is fine, but you also have to include them in your therefore statement. So go, pause this, copy out the solution, and then move on to the next one. Okay, so we're going to do the same thing as before, a rough sketch and then a detailed sketch. A bridge 320 meters long spans a valley. From the ends of the bridge, the angle of depression of an object on the ground from an object on the ground below are 46 and 68 degrees. Find the height of the bridge above the object. So let's do our rough sketch. We have a bridge, which is usually part of going over a valley or something. We have an object, so put a little object. We have an angle of depression from both ends of the bridge. So I get one angle of depression looking down and another one looking down. It looks like I made this angle smaller, so I'm going to call this 46 degrees. And I'm going to call this 68 degrees. It wouldn't matter if you swap those two, you'll still get the correct answer. It's just a matter of looking at the bridge from the other side. I'm looking for the height of the bridge above the object. So I want to find out what this height is. That'll be 90 degrees there because you're going straight down. And we get 320 meters all the way across. I think that's about it. So again, you're going to go and draw this much nicer when you see my nice picture with straight lines. So one common mistake that people think is that this bridge is cut in half by this, and it is not. Okay, so I got lots of people that say that this side is equal to this side, and they just cut that in half and make the question a lot simpler than what it's supposed to be. That would only happen if these two angles were the same, and they are not. So it is not cut in half at this spot. So let's go look at the solution. So there are three triangles here. There are two right angle triangles. Include those right angles right there. So we have two right triangles, so this one and this one. And we have one very large triangle there that's on the outside. Now I want to figure out what H is right here. So I'm either going to have to use information from one of the right triangles to give me some other piece of information, but that's unlikely, or I'm going to have to use the large triangle right here to either give me this or this. The reason it's going to be those sides is because I'm eventually probably going to do the 46 degrees and do an opposite over hypotenuse, or do the 68 degrees here and do opposite over hypotenuse. That's the only way I can see it working out. Let's include some extra angles. I could go and figure out what this angle is, or this angle is, or this entire angle right here, which is what we need to do to be able to find one of these sides. So we do 180 minus this, which will give me this angle. So we label that 66 degrees. We're going to let H represent the height of the bridge above the object, which is what we're going to be looking for. And then we have to decide, we're going to end up doing sine of 66 degrees over the opposite side, 320, because I know an angle on the opposite side, so therefore it's sine law. And then I'm going to either do the 46 degrees over this side or the 68 degrees over this side. It's usually better to go for the bigger angle if you can, so I'm going to call this X right here. And we're going to go and find X. So let's go and find out what X is. So we're going to do, I've already said it, we're going to do 320 over the sine of 66 degrees, and we're going to do X over the sine of 68. The reason I chose that configuration of the sine law is because we like our unknowns in the top, in the numerator. We take the sine of 68 degrees over to the other side, it'll be multiplied, and we end up getting 324.7773. We take the extra decimal places because I'm going to need to use that over here. Now that I know something in this triangle, I can circle my 46 degrees, and I can do opposite over hypotenuse. So I do the sine of 46 degrees, opposite, which was my h, over hypotenuse, which we found to be our x. Bring this to the other side and multiply, and I get 233.6. And again, I'm going to have to do a therefore statement, so scrolling down a little. Therefore, the bridge is 233.6 meters above the object. That covers it for tonight. You'll take note of the homework down there. We've made a few corrections to the answer in the back of the textbook. Number 2, I think, had the wrong answer in there. So when you do your homework, make sure you recognize the fact that there's 2 answer corrections right there. And we'll do that tomorrow in class. Hope you guys have a good night. Take it easy.